Hello, welcome. Let's try to solve another Leetcode problem. 3183, the number of ways to make the sum. We are giving an infinite number of coins with 1, 2, and 6. So our coins is just 1, 2, and 6. And we are only gave 2 coins with value 4. Yeah. So for the value of 4, we only have a maximum 2 values. Yeah. So it means we can only maximum use the 2 times of this number 4. We can use 0 time, 1 time, or 2 times. So we're going to return the number of ways to make the sum of n with the coins we have. So for example, if it is 4, we're going to have 4 ones, 2 1 and 1 2, and 2 2 and 1 4. So there are 4 ways. Yeah, so as the answers may be really large, so we're going to return a modular and 10 to the power of 9 plus 7. So this is just an example. 223 and 232 is going to be the same. So this is a typical unbounded knapsack problem. But if we are solving it by using the DFS directly, definitely we're gonna have time limit exceeded. So I also prepared some examples. Maybe we can try this one. Yeah. So this example is DFS plus memorization to solve the problem, but it didn't work, as you can see. So I prepared an unbounded knapsack, and this is the mod, and from the beginning I'm going to call fi, starting from 0, so this is my nums, it's going to be 6, 2, and 1. And then I'm going to check the total nums, because the input going to be this number n, so if this t is the total nums, it's the target. If it is less than 0, we're going to return 0. If I equal to n, it means the length of nums, so I'm going to return 1 if t equal to 0, otherwise I'm going to return a 0. So now after that, I'm going to plus all the cases. So this is a not ticket, and this is we're going to select it. But if we select it, I will not be updated to the next one, because this is unbounded knapsack, and this t is going to be minus the nums I. And finally, the answer going to modular mod. Yeah, it can pass for some testing cases, but it cannot pass all testing cases. Yeah. So this is a typical DFS plus memorization. Yeah, so if I submit it, definitely it's gonna have time limit exceeded. So this means for such problem, we're gonna, yeah, as you can see, it's gonna be time limit exceeded. So if this n gonna be a really big number, so for example, n is gonna be nearly to 10 to the power of 5, it didn't work. So this means for Python, I'm not sure if other language works if we use memorization, but for Python, we cannot solve it like this way. We have to use dynamic programming. It means a tabulation to solve the problem. So we're going to turn this problem into a dynamic programming directly. So it's going to be similar. So here, this is the mod, and now we're gonna let me just prepare the nums. So we're gonna put the nums here, because we're gonna turn this problem into a tabulation. So for any value inside the nums, and we also need to prepare a dynamic programming array. So it's going to be from beginning, it's going to be 1 times 0 times the length of the nums. So this is just from the beginning, we're going to prepare a 1D DP array. And inside of this 1D DP array, we're going to just update this f array values. So for any value I inside the nums, so we're going to check another value j. So for j in range from I to n plus 1. So this is the n. So if n equal to 4, it's going to be 4 plus 1. Yeah. Now we can update all the values. So we're going to update from this fj. Yeah. So this is why we're going to turn this unbounded knapsack. We're going to turn this DFS to the real dynamic programming. And maybe from the beginning you are not familiar with it, but after practice a little bit, this is going to be just the same as DFS. Yeah. So we're going to update it like fj plus the value before it. So it's going to be fj and minus I, and modular a mod. Yeah. So let me just use an example. So from the beginning, we're going to prepare a 1D array, and the first place is going to be 1. This means if this is a 0, yeah, if we find the index 0, basically it means we find one combination. Yeah, so this is why for the index 0, we're going to prepare a 0, and for other places, this is going to be like 1, 2, 3 and 4. So from the beginning, it is always to be 0. All those places. This is our definition of the DP array. So this is the F. Now we're gonna for I in nums, and I in nums, I is just 1, 2, and 6. So for 1 inside of the nums, we're gonna start from this 1. So F1 gonna be equal to F1 plus F1 minus 1. Gonna be 0 plus 1. So this place gonna be updated to 1. Yeah. And similarly for this 2, so it's gonna be for z equal to 2, so F2 gonna be F2 plus 2 minus 1. Yeah, 2 minus 1, it is F1. So this means 0 plus 1 here gonna be updated to 1. And similarly for this place and for this place, it's gonna always be 1. Yeah. Now let me clear a little bit about it. Yeah. So all those zeros will be updated to 1. So this means if we only have a choice of value 1. Yeah. Now we want to use the values of 2. So 2 gonna be here. So it's gonna be for this F2, it's gonna be F2 plus 2 minus 2. 2 minus 2 is 0, this is 1. So it means 1 plus 1, this one gonna be updated to 2 if the n equals to 2. So if n equal to 3, so this means z gonna be equal to 3. So F3 gonna be F3 plus 3 minus 2 F1. So this means this gonna be updated to 2. And similarly for this 4. Yeah. So this means F4 gonna be equal to this F4 plus 4 minus 2 F2. So it's gonna be 2 plus 1. This gonna be updated to 3. Yeah. Did I do something wrong? Let me check about it. Yeah, I think I did something wrong. Yeah, I think this is okay. So currently everything is okay. So for this F4 n equal to 4, so we're gonna return a 3. Yeah. But currently we only include 1, 2, and 6. We didn't include any number about this number 4. Yeah. So this means we can still use this 4. If we use 1, 4, we're gonna plus another 1. Yeah. So this is why the answer gonna be 4 instead of 3. Yeah, because we can still choose a 1, 4, 0, 4, or 2 4s. Yeah. This is why. Now let's just finish the coding. So we don't need to use this anymore, and from here we just need to have a final check. Yeah. So we're gonna prepare the result. It's gonna be Fn. Yeah. Now we're gonna check if n more than equal to 4. So the final result I'm gonna plus equal to Fn minus 4, and here if it is more than 8, this means we're gonna use 2 4s. It's gonna be Fn minus 8. Yeah. And let me clear here. And the final result is gonna be result modular in the mod. Yeah. Now let me just run it to have a check if it works. Yeah. So here needed to use a plus. So it's gonna be the first one gonna be 1 and plus 0 times the length of the nums for this nums. Here inside actually we need to use 1, 2, and 6. Yeah, because only in this way we can build the array. Because for the dynamic programming and for the 1D array, we need to use the smallest coils first, and then we're gonna use the biggest coils, because in this way we can call all the combinations. Let me just run it. Here the index goes out of the range. Yeah, because this is yeah, so this is the this is the nums. Yeah, let me just to check what gonna be z and z minus I. Let's just check why it goes out of the range. Maybe we can find why. Yeah, so here this is 1, 2, 3, and 4. For this j, so the j is okay. So the z minus I, it is also okay. Yeah, let me think about it. So this is fj plus fj minus I. So for any coil inside the coils, let me just use the coils. Yeah, so this is the length of the this is not the length of the coils, so this is n. Yeah, because we're gonna because for our DP array, we're gonna design this DP array. This is just the coils. It means how many coils. Yeah, and this is the DP array. So we're gonna choose the maximum value is gonna be n. Yeah, and now for any coils inside the coils, we're gonna check it until to this number n, and then we're gonna just update the f and j. It means we're gonna find all the possible ways, and finally we're gonna model a mod. Now let me just run it. Now as you can see, it works. I mean, here I did something wrong. It is not length of the coils. It is not the length of the coils. It is this number n. This is our design of this DP array, because finally we just want to check this fn. It's gonna be the number of combinations. Yeah. So it is a little bit about the different writing, but this is basically an unbounded knapsack problem. As you can see, it works. After we turn this DFS into the real dynamic programming, and it works, and the speed is like 2 seconds. That is why if we use the DFS plus memorization, it didn't work. Yeah, so I think that's all about it. Thank you for watching. See you next time.